Hi. So this chapter is chapter 7, Simple Interest and Simple Discounts. First of all, we're going to look at the interest formula. So what we think about is that we want to have enough money to run our businesses, the leftover, the profit. So this is kind of related to that. Sometimes businesses don't have enough money, and so they have to borrow money just like we do in our everyday lives. But we also have to pay interest when we borrow money, right? So this is what we are going to talk about in this chapter is the simple interest and simple discounts. So whether we're talking about a loan or a savings deposit, we are going to compute the interest using the formula I equals PRT. So we want to make sure that we remember what each one of these stands for. And then when we have the problems, we can easily plug in the different amounts. So I is the dollar amount of interest paid or received. And that's usually what we want to find out. Sometimes we'll find out some of the other parts of the problem, but that's for the main ones we're going to talk about will be that for the first ones. P is the principal. That's the original dollar amount, typically, of the amount of the loan or the amount you deposited in the savings account. R is the rate or percent of interest per period, and that's really important that we make sure that we get that right. When this formula, we usually use decimal or fraction, so we could use either one, both will work. And T is time. And we need to look at that in the same period as we have the rate. Unless it's specifically noted, we're going to look at the period used as a year. So when we look at that, we will see your first example. Karen deposits $650 into a savings account, earning 3% simple interest. How much interest will be earned in 4 years? Now, we are talking about simple interest here. We will be talking about compound interest later, but let's just look at the simple interest now. So we would say interest is equal to PRT. So we know the principal from the problem is 650. So we have 650 times 3% simple interest, which would be 0.03, because remember, we're moving the decimal point over 2 places to the left. And we're going to multiply by the time, which is 4 years. So the computation would be 650 times 0.03 times 4, which will give you $78. So she earned $78 of interest after 4 years at 3% per year. In this example, we are looking at a company that borrows some money, and we're going to look at how much that they would have to pay to the lender. And so we do the I equal P or RT again. And in this case, at the end of the 8-year period, the construction company would have to repay both the $150,000 in principal and the $156,000 in interest to settle their loan. So that does sound like a lot, and it is a lot. So it's really important for companies to determine, does this make sense for us to borrow money? And could we do it in another way? Or, what's going to work to help us to get profit for our company? This example, it's basically the same, but we're using that fraction instead. And so we are going to look at it 2 1/3% for 5 months. We could also do the 0.0233 if we wanted to. It would be 7/3 or it'd be 0.233. So we're looking at an annual rate and we say 5 months because it says 5 months. So we're dividing 5 divided by 12 because that's the time period. So we found out that the interest was $3.61. We want to be looking really carefully about the decimal points again, the number of digits when rounding. Try to keep as many as possible for as long as possible, and then so you have the best accuracy that you could have. We also have two types of loans. We have simple loans and we have fixed payment loans. So, with a simple loan, you get a certain amount of money, which will be repaid on the maturity date along with that extra interest. But you don't have to pay anything prior to that. So that would mean that they're usually short-term loans. A fixed payment loan, you get a certain amount of the proceeds, but you're paying them in equal payments on a regular basis, and these are mostly long-term loans. So we'll look at that. Well, first we'll look at a short-term. Sophia borrows $1,459 at 1.28% per month. Simple interest for 10 years. We want to find the interest. Remember to be very careful about what the problem is saying. This one says simple interest and it says 2 years. So we want to say 24, right? Because it's 24 months. Because the problem also says 1.28% per month. Okay, so watch that carefully. So then we just plug it into the formula. 14.59 times 0.0128, which was our 1.28%, times 24, because it was 2 years, so 24 months. And then we get the interest that was earned on the loan. So we also have to take into consideration, remember we've talked about before the number of days in a year and how the leap year could be different and all that. Well, we talk about exact interest and ordinary interest. So if a problem, or if, when you're doing this in the business world, if it talks about exact interest, we're going to use 365 days or 366 if it happens to be the leap year. But if we look at ordinary interest, we're going to divide it by 360 days. So make sure you're looking at it. Here's your first example. Ethan borrows $600 at 13% exact simple interest for 75 days. It says exact, doesn't say it's a leap year, so we're going to go ahead and use that 365 days to find the interest, and we will plug in the amounts. We have the 75 over the 365 that we used for the time, and so we find out that we get, when rounded, $16.03 in interest. This one says ordinary simple interest. So when it says ordinary, we have to use 360. So there's a little bit of a difference. If you look at it, it's the same numbers, but we're looking at it whether it's exact interest or simple interest. So with an exact interest, he would have received $16.03 in interest, but at ordinary interest, he would have, he will owe $16.03 in interest, and at ordinary interest, he would owe more. He would owe $16.25. So let me look, make sure that I am. Yeah. The other thing that I wanted to make sure, let's see. Typically long term, we talked about that. We would typically use the ordinary interest when we're talking about if the time is stated in years. Okay, so that's if you see it stated in years, that's when you're mostly going to have the ordinary interest. Okay, example 7. Geraldine deposits $8,000 into an account earning 3.5% exact simple interest on April 5th and withdraws it on July 11th. How much interest was earned on the account from the day of deposit to the day of the withdrawal? Remember that chart, that table of days? It comes in handy when we're doing this. So what we want to do is, it does say days, and it's exact interest. So we know if it's exact interest, it's the 365. Again, we saw days, so we know that it's not the ordinary, because that would have been stated in years. So we look at 8,000 times that decimal rate of 3.5%, which gives us 0.035, times when we look at the from April 5th to July 11th, there's 97 days of interest. And so we use the 97 over the 365, and we find out that the interest earned on Geraldine's deposit would be $74.41. Okay, again, this example, you're going to use the table of days again. Frost Frozen Treats borrows $35,000 at 7 5/8% of ordinary simple interest on September 16th and repays the loan on May 12th of the next year. So we want to find the interest earned. So you just make sure that you look at the chart, the table of days, and we would find that there were 106 days left in that current year, and then we have to add that to the 132 days in the next year. So make sure you're doing that. Make sure you look at the fact that it's going over for another year. So we would find out that the interest we'll earn on the loan was $1,764.34. Remember back when we were looking at the formula, the PBR formula? And remember how we were able to cover up part of it, and then we would be able to figure out how to do the rest of it? That's the same thing on this one. So it's just another way for you to look at it. If we covered I equals PRT. If we had covered up the P, we'd get I divided by R times T. So it just gives you an example of how you can work it out if you want to do it that way with that diagram. So Jennifer received $360 in interest over the last 2 years from a savings deposit, earning 2.5% simple interest. Find the amount of her deposit. So in this way, we know the interest, we know the time, we know the rate, but we want to know the principal. So that's why if we look at that back up here, we know we're looking at the principal. We can either cover up the P in the diagram, which we would get I divided by R times T, which is also found in the formula. And then we would just do our multiplication and divide, and we get $7,200 as her initial deposit. Okay. Another thing to think about is order of operations in this one. So make sure that parentheses come first. And if you're putting it in a calculator, you want to make sure that you do that portion of the problem first. So we want that 0.025 times 2 is basically going to be done first before you do the division. Another example, $700 and paid $336 simple interest in 6 years. Find the interest rate. So we're looking at a different amount for that one, but we just basically do the same problem and find the interest rate. In this example, we want to find time. So basically, it's the same formula. We're just moving it around based on what we are looking for. Here's how much did she borrow. Okay. So here again is a time one. How many days was the loan outstanding? And you can figure that out based on 360 days in a year, and we can find out how long she borrowed the money for. So different ways of looking basically at the same thing. This one is a little bit harder, maybe. At 8% simple interest, how long would it take for an investment to double? So we want to find the time, right? How can we do that? Can we figure it out? Basically, we really can. So we're looking at, in here, we don't have the specific dollar amount, but we're like, we can plug something in. We've done that before, remember, on some of these problems. So we're going to say the principal is 100. If it doubles, it would be 200 total after some time period. So we would figure that out based on that. $100 is the interest. So $100 divided by 100 times 0.08, and we get 12.5. So it would take 12.5 years for that investment to double. Section 7.3, we are going to look at adding interest. We are going to look at the amount the borrower receives, and we are going to look at the maturity value and other words, terms we're going to look at is deposit, initial balance, future balance, maturity value. So we want to figure out how the interest is calculated on the simple loan. Again, we're using the same formula as we did before. So just some other terms, the maturity value is basically the total of payments that you're going to be making. The proceeds would be the amount financed, and then we would get the interest from that. So those are how those terms are used in these examples. So Victor borrows $6,000 at 14% ordinary simple interest for 90 days. Find the maturity value of the loan. So the maturity value is the total of the payments that they would make. So we're not just looking at, when you do the formula, you're still using that same formula, I equals P times R times T. You get the interest rate, which is 210, but that's not going to give you the right answer, because the maturity value is the total of the payments. So it would be the $6,000 in principal plus the 210 interest that you figured out in the problem. And so he would have to pay back $6,210 at the end. Okay. On this one, we're going to use the table of days again. On July 31st, Ashley signs a $5,000 simple interest note earning 14% ordinary interest due in 60 days. Find the due date, interest, proceeds, and maturity value. So basically it's the formula again, right? We're looking at the table of days to figure out how many days there were between it, and we do the I equals PRT, And that's how we get the answer of that she will pay back $5,116.67 on September 29th. Remember again that this is giving you the $116.67 is the interest. So make sure you look at what is being asked for. So we get some more of the same thing. Just remember, plug them in as it is asking you for. So if we know the principal is $4,000, okay, he borrowed $4,000. So we know it goes in that bottom left portion of the denominator. The maturity value is $4,250. Subtracting that, we find the interest of $250. Okay, so you're not putting $4,250 in that top rate. Remember that that's the maturity value or the total of the payments. We want to make sure we use the interest instead. So that's where we find that formula, and we can find out the interest rate based on that. On this next one, we are looking for the principal and the final balance. Okay, so first we're looking at the principal, and we get that $18,750, but we know that there was $375 in interest on it, and so when we add those together, we can find out the amount, the final balance. Okay. We are coming back to these wonderful percent change diagrams. We can use those again in this section as well. So we will look at first this one example. At 4 years, after 4 years at 6% per year, simple interest, the balance in Bill's account will be $3,410. We want to find the principal and the interest. So in that case, we can set up this little chart. We know that the 3410 is the new amount, so we can put that in that bottom right corner because we're saying the old plus change is equal to new, right? Remember that? The old percent is 100%, so we'd use that at the top. The change percent is 6% per year times 4 years, which gives us 24%. See how that's done? The 6% per year times 4 years. Then our new percent would be 124. And then we do that wonderful cross multiplying, and we can find out what the principal was before the original, with the original. We can do the same thing. This one is an 80-day simple interest note earning 15% exact interest, has a maturity value of $1,282.83. Find the proceeds and the interest. Okay, figuring out the same way, doing the cross multiplying, we find that 15% times 80 over 365. Remember, it's an 80-day simple interest note. So we're looking at an exact interest, so we're looking over 365. So we get that dollar amount or that percentage, and then we know that the new percentage is 103.28 something-ish. And then we saw the proportion to find out the answer for that one as well. So just an easier way, again, to work those problems by putting in that chart that we've already talked about. So hopefully, if you like that chart and you like working out problems there, this is another way where you can use those. The next section is discount interest. So interest is not always added to the principal. Sometimes it's subtracted. So that's why we call it discount interest. After subtracting the interest from the principal, we obtain the proceeds. When using discount interest, the principal and the proceeds are not the same. the principal is the maturity value. The computation is exactly the same as before. So we're looking at I is equal to PRT. So let's go through it, and hopefully this will help explain a little bit better. Travis borrows $750 at 8% ordinary discount interest for 90 days. Find the interest and proceeds of the loan. So when you think about discount, what do you think? You think about subtracting, right? Okay, so when you see that discount, we're subtracting. So we use the same formula. We know that he borrows 750 times the 0.08 for 90 days. We are looking at the ordinary interest. So it's 360, so 90 divided by 360. And it gives you 15. The interest is 15. But we have to remember that we're looking at discount. So we're subtracting the 15 from the 750 principal to get the proceeds of $735. So a simple discount note is one that we can look at this again. We have the example of that. It was dated August 7th for $9,000. It's payable in 90 days at 12% ordinary interest. We want to find the due date, the interest, the proceeds, and the maturity value. So again, we're using the table of days, and we calculate it based on the number of days, which we get is 90 because it's 309 minus 219. Again, we are using ordinary interest, so we've got that 360 days. Then we subtract the $270 interest that we got from the formula, and the maturity value is $9,000, but the proceeds are $87.30. Again, we can use a percent change diagram, and we're basically doing the same thing here. We're subtracting instead of adding. So the 100 minus the 2.5% that we got was the 97.5. Basically setting the rest up the same exact way to get our answer. A lot of times when we're talking about discount interest, we're looking at treasury bills, T-bills, bonds, and what we're looking at is the government is borrowing money from the investor. So if the dollar amount of it is $10,000, we're going to look at a discounted rate so that the consumer only has to pay a portion. They don't have to pay the whole $10,000. They would pay a portion using the discounted rate. So they could borrow a $10,000 T-bill and only pay, in this example, $9,918 for it, as opposed to the $10,000. And typically what it is, there's a certain time frame that each one of those, until it matures. And at that point, you at least get back your $10,000, the $10,000 of the original, even though you paid $99.18. So, you're looking at $82. That's not a lot, but I mean, you're giving the government some time to have that extra little bit of money, and you both get benefits out of it. Another discount problem. On June 7th, Jones Bar and Grill signs a $12,000, 12% ordinary, 120-day simple interest note for supplies purchased from Anita's Restaurant Supplies. So this is getting a little bit more convoluted because Anita sold the note on June 25th at 11% ordinary discount to Tony's Financial Services. Tony sold the note to the big bank on July 1st at a 10.7% exact discount rate. Find the proceeds of each transaction. What does this all mean? for example, maybe you've seen where you borrow money from a certain entity, a certain bank, and then all of a sudden it's like, well, so and so is handling your account now, or so and so is handling this now, and it's not the original one. So what banks are able to do is they are able to basically get their money back um, quicker, and maybe it's also more reliable than worrying about the consumer being able to actually pay the bill. The consumer is actually still paying the same amount, but the amount that the companies are paying for it are smaller. So he still would owe, so it looks like the last one is, in this one, is Big Bank. And he would still need to pay based on his original transaction. But after Anita bought it and sold it, she could make some money here and there. So, it just all depends if, big companies can do that. They're looking at, of course, making money. And so we still can use that interest is equal to PRT to figure out the different amounts that is discounted for the next company that is getting the um, the note. When we look at rates, so that's part of the I is equal to PRT formula. We want to look at the effective rate of a loan, which is the money available to the borrower as the principal. For the simple interest loan, the principal is the proceeds, and the exact interest is used if days are counted. So we talked about all that already. In 1969, we got the annual percentage rate from the Truth in Lending Act, and we can actually have a formula based on figuring out the annual percentage rate. And it's the same, the effective rate and the APR. We're doing the same basic formula. We're trying to find the rate on that one. The effective rate might not be the same as the nominal rate. So there's where you're going to get different answers, and it might seem like it's not correct, but unfortunately it is. So the effective rate on this one, when you figure out of the $940 60-day 12% ordinary simple interest note, is 12.17. So even though the rate is 12%, we're really looking at a 12% ordinary simple interest rate is 12.17. So just know that they're not going to be equal. They're going to be close, but they're not going to be equal. Because for this example, you're looking at 11% exact interest, but when you look at the effective rate of the $5,600 for 90 days at 11% simple discount, you're looking at 11.31%. Again, you're using the same formula to find the different answers. Make sure that if it's, depending on whether it says actual, simple, exact, that you're using the right numbers that it's asking for. So is the effective rate ever the same as the nominal rate? Well, it can be, but there has to be certain things that have to be in place. So the loan has to be a simple interest loan. It doesn't require any fees, which we'll talk about that. And I'm sure you might have seen that, in your daily life, that you have fees on a loan. The loan adds the interest to the principal, and the loan uses exact interest. Again, exact interest, we're going to use that 365 or 366 days, not the 360. Okay. So let's look at the first example. Find the effective rate of 11% exact discount loan for 90 days. So again, we're using that I equal PRT. And we don't have to, in this one, we don't have to have a specific dollar amount, but we can look at any one we want. So we're just looking at $1,000 just to make it a little simpler. And we find out the interest. And then we find that the effective rate, again, it's going to be a little bit more, a little different than the 11%. It will be 11.31. Yeah, I was looking at the finance charge. So the total value of all fees and interest is called the finance charge. The finance charge is used in place of the interest amount when we're looking at effective rates. We also want to think about fees paid, which I talked about a little bit. If borrowers have to pay a fee toward it, that's also computed into it. So for example, Julio borrows $3,000 for 90 days at 13% original discount interest and pays a transaction fee of $50. And what is the effective rate? So we're adding in that $50 transaction fee to ensure that we get the correct amount. If you've ever taken out a loan, you know that they add interest on it, and also that if you don't pay enough, then you might just get behind because you're only making partial payments. So if you're not at least making the principal, it's going to be hard for you to ever get to figure out the total amount. So we do look at different ways to where payments are made. One of these is called the actuarial method. So we're looking at payoff amounts. And basically you would see this on most any loan documents that you would get, and it would show that if you paid this much by this date, this is how much you would owe. And then your next payment would be this amount, and then you would keep going from there. So on this one, we just want to know the payoff amount on the maturity date of the note. So we look at that in this formula. It says he makes a payment. So he made a payment. So we're subtracting that payment, but we still got to take into consideration the interest that would have accrued during that month. So it was originally the $25,000 times the 0.14 note times 1/12, because it was interest for 1 month. Excuse me, right? Because it was between April 7th and May 7th. So then we find out that the amount that is owed. So here's the little table, and you can set it up like this. Like I said, banks typically will set it up for you so that it's part of that truth in lending. So you know exactly if you make this dollar amount, this is what it's going to be. And so you can figure it out in this table too. And here's the example of the date, the charges, the payments that were made, and then the balance. So this is a big difference. Okay, he paid off the $8,000, which was $17,291, but then after 6/7, his balance was $17,493. So it's like he didn't pay anything at all. So that is something that you need to really take into consideration too when you're looking at paying off your bills, or if a company is looking at paying off their bills, does it actually make sense? Or should we make a partial payment? Or is that partial payment even going to be worth it? Or is it going to be detrimental to us in the future? So we want to really take that into consideration um, when we are looking at making payments. So besides the actuarial method, we can look at the United States rule, which is based on a case. If you want to look back at the case, you can. It's talking about, it was from 1822, and one person owned somebody else money. And so it's how and when interest is computed. And so when we look at the U.S. rule, we're looking at interest computed by counting days between transactions, and that the interest is computed only on the outstanding principal borrowed, not on previously unpaid interest. So it specifies a method by which payments are applied to a balance. It does not specify whether regular payments are necessary, when a loan should become due, or whether ordinary or exact interest should be used. But typically, of course, lenders will put all that into place with that, but it does not required when you're looking at the U.S. rule. So you see how this was set up. Again, you're using that I equals PRT, and then you can set up the chart again and figure out what the principal balance would be based on making the payments. So it shows 24 days, 31 days, 54 days. So how much the person would need to pay on a certain date to pay off the loan. This example, on February 12th, Pamela borrowed $8,500 at 12% exact interest for 180 days. She made partial payments of $300 on March 1st, $40 on April 1st, $80 on May 1st, and $200 on June 1st. What is the payoff amount on the due date according to the U.S. rule? So remember, think whether it's asking you for the actuarial method or the U.S. rule. So we can set up the table and look at what happens. So it doesn't help when you look at the balances and everything to pay those partial payments. Sometimes it's better to just, if you've got a little extra, save it all up until you get more than what the principal is, so that it's actually worth you putting that money in. Because the partial payments on April 1st and May 1st were smaller than the accrued interest. So the principal was not reduced. So that's something to consider, to take into consideration. Okay. As a final little thing for this section, the actuarial method keeps track of the total balance, while the U.S. rule tracks the principal balance. So they're the same unless that accrued interest goes unpaid. And that happens when a payment is smaller than the computed interest. So there we go with Chapter 7. Hopefully this has enlightened you a little bit on simple interest and simple discounts. We will go further into interest, but we're going to talk about compound interest in our next chapter. So please let me know if you have any questions, if I can do anything to help. I am here for you. Thank you.